Here's a table showing water height on a beach over time due to tides. So, all right, we got time 0, 2, 4, 6, 8, 10, 12. This happens at hours. The height of the water height on the beach is 3 at hour 0, and then 5 feet above ground, and then you see it. So it goes 3 to 5 to 7 to 5 to 3 to 1 to 3. So something that's periodic. And it looks like it repeats quite often. All right, so using the table above, determine the amplitude of the tides. So a quick graph, right? Here we are at, what are the numbers that seem to matter? We have 1, we have 3, we have 5, and we have 7. And then the numbers that matter seem to be 0, 2, 4, not drawn to scale, 6, 8, 10, 12. 0 matches up with 3, 2 matches up with 5, 4 matches up with 7, 6 matches up with 5, 8 matches up with 3, 10 matches up with 1, and then back to 3 again. Okay, so periodic in nature. I don't know if it's wavy, I don't know if it's jagged, I don't really care. What I do know is that if it is periodic and I need to find the amplitude, I care about half the distance, the y value distance, or rather half the total height created in this graph. So you take your maximum value, which is 7, you take your minimum value, which is 1, and you take half of its difference. Half of 7 minus 1 is half of 6, which is 3. So there you have it. There you have it. Oh, like and subscribe, please.